Right now, there is a star exploding somewhere in the universe, a billion-ton shockwave expanding at millions of miles per hour in a blaze so bright it outshines entire galaxies, and you will never hear a single sound from it. Welcome to space, where the most violent events in the universe happen in absolute, perfect silence. And that's just where we're starting. Sound needs something to travel through: air, water, solid matter. It works by compressing molecules together in waves. Without molecules, there is no compression, no wave, no sound. Space is not just quiet. Space is acoustically nothing. The vacuum between planets and stars is so empty that sound cannot exist there at all. If the sun suddenly exploded right now, you wouldn't hear it for over 8 minutes, and even then only because Earth's atmosphere gives sound something to move through at the very end of the journey. Every rocket launch, every movie explosion, every roaring spaceship you've ever heard on screen, Hollywood invention. Out there, there is nothing to carry it. Our neighbor, Venus, has a problem with time. Venus takes 225 Earth days to orbit the Sun. That's one Venusian year. But here's where it gets strange. Venus rotates so unbelievably slowly on its own axis that a single day on Venus, one full rotation, takes 243 Earth days. That means a day on Venus is longer than a year on Venus. You would celebrate New Year before you ever watched a full sunrise. And to make it stranger still, Venus rotates backwards compared to most planets. On Venus, the sun rises in the west and sets in the east, the opposite of every other planet we know. Nobody is entirely sure why. Venus keeps its secrets. When a massive star dies, it doesn't always become a black hole. Sometimes what's left behind is something even harder to comprehend: a neutron star. A neutron star is the collapsed core of a dead star, a city-sized ball of matter so compressed that protons and electrons are crushed together into neutrons, packed shoulder to shoulder with nothing in between. The result is almost beyond imagination. A single teaspoon of neutron star material would weigh roughly 1 billion tons, more than all the humans who have ever lived combined, crammed into a space smaller than a sugar cube. Some neutron stars spin hundreds of times per second. We call those pulsars. They beam radiation like cosmic lighthouses, sweeping the universe with pulses so precise that astronomers once used them as clocks. One of the most accurate clocks we know of is a dead star. Black holes do not just pull things in, they reshape reality itself. Einstein's general relativity tells us that mass warps the fabric of space-time, the way a bowling ball placed on a stretched rubber sheet creates a dip everything nearby rolls into. A black hole is that effect taken to an extreme. So much mass compressed into such a tiny point that the dip becomes a cliff, and beyond a certain boundary called the event horizon, not even light can escape. But the truly unsettling part isn't the gravity, it's what black holes do to time. Time runs slower in stronger gravitational fields. This isn't science fiction, it's been measured on Earth using atomic clocks at different altitudes. Near a black hole, the effect becomes extreme. An astronaut hovering just outside the event horizon might experience 1 hour, while thousands of years pass elsewhere in the universe. They would return unchanged. Everyone they knew would be long dead. Time is not fixed. Gravity bends it, and black holes bend it most of all. We're not done yet. The sun accounts for 99.86% of all the mass in our solar system. Every planet, every moon, every asteroid, every comet, all of it combined is less than 0.2% of what the sun contains. Light from the sun takes 8 minutes and 20 seconds to reach Earth, but that same light spent roughly 100,000 years trapped inside the sun itself, bouncing from particle to particle through the solar core before it ever reached the surface and shot off into space. There are more stars in the observable universe than grains of sand on every beach on Earth. The current estimate is around 2 trillion galaxies, each containing hundreds of billions of stars. The number is so large, it has no emotional meaning. Your brain wasn't built to hold it. And perhaps the strangest of all, about 68% of the universe is dark energy, a force accelerating the expansion of the universe, and we have no idea what it is. We cannot see it, touch it, or directly detect it. Only know it's there because of what it does to everything else. The dominant force in the cosmos is a mystery. A day longer than a year, a teaspoon that weighs 1 billion tons, explosions happening in absolute silence, time bending around collapsed stars, a universe 68% made of something we can't explain. These aren't footnotes, these are the main story. We look out into the cosmos and see something vast, silent, and mysterious. A universe that follows precise rules, yet still holds countless secrets. And maybe that's the most extraordinary part. In a universe filled with darkness, silence, and immense power, we are able to observe it, question it, and search for meaning within it.